Hi, I'm Walter Grayman, representing the Environmental and Water Resources Institute, EWRI's Water Distribution Systems Analysis History Project. The purpose of this project is to document the history of water distribution system analysis. An important part of this project is a series of interviews with engineers, modelers, researchers, practitioners who have made significant contributions to the field of water distribution system analysis. Our interview today is with Sudhir Kshirsagar. Sudhir has been active in the field of civil environmental engineering and related technical fields for the past 40 years, with emphasis on water distribution system analysis over the past decade or so. His entire professional career has been spent in the private sector, including heading his own firm, Global Quality Corp., since 1993. This interview is being held in Palo Alto, California on December 29th, 2019. Sudhir, can you give us a brief history of your educational and employment background that led to your present-day interest in water distribution systems analysis?
Thank you, Walter. My bachelor's was from IIT Kharagpur in electronics and electrical engineering. And afterwards, I went to Indian Institute of Science in Bangalore, now known as Bengaluru. After that, I went to University of Illinois. And from University of Illinois, after my PhD, I think you are the one who you hired me to work for your company, which was leading the 3D GIS back in 1983. So how did I end up from electronics to computer science master's to a PhD in environmental systems engineering? A variety of factors. From IIT Kharagpur, it was a natural transition to wanting to do something in computer science, both electronics and software, because remember, this was 1975 when I got my bachelor's, and things were fairly emerging at that time. Indian Institute of Science was a very well-known institution in computer science. Over there, I had the fortune to work under a professor who had just come back from a sabbatical in Manchester, and he was very much into use of digital simulation tools, and the specific work he had done was in water distribution systems. So although as a computer science student, we picked up the domain as being water distribution system. This was 1977. And then we were actually looking at optimization of water distribution systems, and which was based on some innovative algorithms that he had thought about. Now, the implementation of the concepts were using Fortran and punch cards, and those programs were run on an IBM mainframe, and we didn't really had to wait overnight to get a job done with the consistency. And so it was difficult to develop software. Nonetheless, we got some good results. Based on those results, I said that I really don't want to do much more of pure computer science. I love this combination of engineering with computer science, and I applied to a few schools. And it turned out that Urbana actually had a fair bit of environmental systems work going on, for a while there. And they saw my work, and it actually worked, interfaced with some of the work in water distribution system that was going on there. So then, before I joined the PhD program in Urbana in environmental systems engineering, of course, when I ended up there, they looked at my coursework and said, "Oh, you really don't have any strong senior level classes in environmental engineering. So I think you'll be better off taking some senior level classes." So almost therefore started with water chemistry with Professor Snowing, and he was the best teacher, and that was the first time I enjoyed chemistry. And we actually debugged his first textbook that came out that time, and he was, I know he still works, so it's someone from Illinois I remember very fondly. So with that educational background, obviously, and Paul Cook, being a graduate from Illinois, and he and you therefore got me to work with Gates and Associates with you folks in in Cincinnati. So that's roughly the educational background and how I made a transition from some of my educational background into what I'm doing right now.
And between when you worked at Gates and Associates to when you started your firm?
So obviously, as you knew, back in '93 when you folks hired me, environmental systems field itself was, environment systems on it, environmental engineering on its whole itself didn't have the greatest job opportunity. So I made a few years of transition into doing other things. I did some finite elements and 3D geometry modeling with a company called SDRC with computer graphics. Then I worked with Procter & Gamble, more doing some big data. Back in those days, we used Teradata and big data and a lot of analysis. So, and I worked the process and total quality, those principles at Procter & Gamble. And so, that took few years in between. But as I did all that, and obviously, we were in touch with you. I saw what the work you were doing and Dick Mills was doing. And I felt that, I could kind of go back to it. And I think, so after I started the company, the first project I did was actually working with you, implementing ArcGIS for EPA and Orsanco. And that helped, kind of launch the career in the company. So that was the beginning of the company, trying to get back into environmental systems back in '93.
You've been in the forefront in the use of advanced computer technology, which you learned, as you talked about, in the water environmental field, including application of computer modeling, Internet of Things, cloud computing, and the specialty area of development and use of inexpensive environmental sensors, for which you're recognized as an industry leader. Can you talk about your experience in those areas?
So I know this is about water distribution systems analysis, history, kind of a background, and clearly I came into water from that, having done the master's thesis and worked with Illinois. But other things happened in Illinois and subsequent, which I see water distribution systems analysis as a piece of the entire water spectrum, and then water spectrum being, source water, drinking water, wastewater, stormwater. And you yourself have done some leading things in spill modeling, which we have now picked up and implemented, and then stormwater work that we've done. So I guess it's come late in life, but seeing water as one thing across multiple domains of water, wastewater, and therefore how does it all come together, and how does computing and hardware advances help us, as some people call the water security, sustainability, whatever words you may use it. So that's kind of a main thing that I'm driven with overall in terms of the vision, but as pieces of it, then doing some very specific things within that is what motivates me most. So for example, back in actually '85, Paul Cook and I worked with the Wright-Patterson Air Force Base, and back then we were discussing back and forth between the GIS and EPNet modeling. So even today, what's something that's kind of done, and the issues related to what is a model versus what is a GIS and what is the truth on the ground. So some of the fundamental things motivated me to continue to explore them on an ongoing basis. And as computer technology develops, database go from being a flat file to something more robust to big data. How can we use the advances in computing? So I have been a proponent of cloud computing for a long time, and we have presented some research related to EPNet in cloud, SWIM in cloud, but we would always get a pushback saying, oh, isn't that not secure? Should we be doing it? And to me, I would say things like Well, we have Office in cloud and other things. So what benefits do we get from doing that in one place versus doing in the other? To me, I think we should be open to the options. And so the same thing runs to, we can wear something that measures our heartbeat and we pay a few $100 for it and we don't think twice about it, whether it's FDA approved, how accurate it is. But when we go to environmental sensing, the pricing of a lot of the same measuring instruments are fairly high, perhaps because a lot of regulations and not as much competition. But remember when you and I worked in Fort Drum for real-time modeling, as we worked with the U.S. Army grant, a lot of the issues were even Fort Drum was more advanced and they had a lot of field data. But even today, in order to get a good operations model of what's going on in the system, it's quite difficult because although SCADA data, it can be now integrated, really field measurements that can be integrated to validate and calibrate the models are still missing. And I think you are the one who actually taught me about the importance of water quality measurements in calibration. I know that's been a theme in some of the work that you've been publishing. But if I go around tomorrow to our utility saying, may I please have your conductivity data to see how well your model behaves, I think the answer is generally well, we just do graph sampling 6 months a month to comply with some rules. So the whole vision is, can we actually improve our knowledge about how the systems are operating? I mean, the modeling is in a sense secondary. The vision is really, what does the customer, being the utility, and their customer, us who drink the water, really want to know, so that we can do a better job of the water security and sustainability and avoid other things. So therefore the whole thing goes into that whole theme about how do we use these technologies to accomplish that goal of the water security.
The general way currently when one wants to instrument the water distribution system for water quality is you go out and you buy a fairly expensive instrument, and once you've installed it and whatever, it can be anywhere from $10,000 to $100,000 for a single station. You've been an advocate of using inexpensive sensors so that instead of having a half dozen of them in a network, we may be able to have 10, 100, 1,000 of them. Do you view that vision as something that can take place?
I think if I ask you the same question, or somebody the same question, is to having a watch that takes 20 measurements and tells you about the whole thing, and if you look at the new startups in the medical space that are going to know everything about your body, and you're going to have personalized medicine. If you ask the same question in medicine to saying, do you think that will be feasible? So that the answer, I think we dealing with the same kinds of challenges. The difference between the consumer technologies versus the ones we want to use in water distribution system, water treatment systems, is the economics, the scale. So when I've gone to venture capitalists before, the usual answer is how many would sell, how many customers would you have, and so the price point is usually dependent on how many you can sell. Having said that, I'm also thinking as we educate the residential customers about knowing more about what's being delivered to their home, and it's coming. We are now having refrigerators that are becoming smarter. So next time you put your glass against to get the water out, it might even tell you the chlorine level, the quality, and so whatever else is going on. It's all about the need, perceived need, and the real need, and people getting educated. I think the new millennials are more up on it than we are. They want to know more. So I think there is as the market develops, then definitely the economics will happen. The main thing is and these definitely are inexpensive sensor, but the usual question that gets asked is, are they reliable enough? Because the notion being something being cheap, therefore it's not reliable. and it turns out that this Internet of Things, that is totally inaccurate, because the same companies that make the best sensors that are going to go in your cars, that actually go into your dishwashers, the same sensors can be easily used directly or adapted to the environmental monitoring. I can give you the names, Bosch, and in ST Micro, and then if you look at the accuracy of the sensors, 1 centimeter or 1 millimeter accuracy in 200 meter in measuring a distance, and so whether you're measuring, so there are the specs on them are really good. So it's not about the sensor. The difficulty in environmental sensing is actually two things. One is getting the data out to where you want it to go to, and in the past we live with somebody will go by and collect it and that, and our meter reading, we do that. So the telemetry, and therefore we are also investigating some new generation telemetry options. The cellular companies are seeing a market, more coming from Europe, saying people are interested in monitoring the environment more aggressively. So all these factors will actually play into water also, for the general environment and for water.
Your entire career has been in the private sector. How do you see private industry, academia, government, and professional organizations working together in the field of water distribution systems analysis in the coming years?
So that's a very interesting question. I've been lucky to have worked with university collaborations in the past, and then been on part of some very large NSF and other proposals to see what the universities are thinking about, and as part of the government projects that we do, as keep the money coming that feeds into research into IoT and cloud-based systems. We've been fortunate enough to work with government organizations, and I think overall the signs are very positive. The main issue I see is actually there is a bit of a disconnect between what the semiconductor industry and the electronics manufacturers have created in the private sector, that's going into our watches and things like that, whereas some of the university research is actually almost going and duplicating the same circuitry and the same boards that are available much more inexpensive. That is changing, because as you see in the last EWRI conference, there were papers based on this Arduino thing that started as a mass movement of people who can create their own devices. In fact, we're going to have opportunity at the next EWRI Congress to learn more about those things. And I met the founder from Italy, one of the founders, Banzi, and then that really struck me. And his goal was, can we enable masses to create devices on their own if they go to a consumer electronics store and buy a component for $30 and all they have is a computer and few wires and that component. And they made it happen. It took time, but they had designers, they had MIT people working with them. But that same kind of a notion and things, I think the same kind of a drive that brings the government organizations and the university, I mean, it's there, but I think more closely, more open conversations. That's the way it happens in software development, where you put out a problem and you get 20 people all over the world telling you how to solve it. And it's happened through some of the open organizations in water for sure, and it's getting more momentum. But I think that needs to go up a couple of notches for that to come together in a lot stronger way.
If you put yourself, say, in 10 years, say the year 2030, what do you see in the way of changes over that period?
I have some actually concerns about where we end up, not in terms of this hardware and software development. I have more concerns about having the fundamentals of what is required to put some of these things together So what I will go back to is it's one thing to take a simulation software for water distribution system, run it 20 different way and come up with the answers, versus really having a physical understanding of what's going on there, and therefore what I'm doing, is that correct, and challenging the model. And then the other thing is, because of marketing reasons, the digital twins, and then I'll joke about it saying, are they quote identical twins? Are they fraternal twins? I mean, to me, they're really not identical twins, because most of the models, as they define, saying and defined to achieve a given purpose, and it's abstraction, just the right level of abstraction to achieve something. So if we don't have that, and I see just like this WSA interviews, a lot of the people are late in their career. And then you see the new generation coming up, but I don't see the same level of engineering intensity. I mean, I've been fortunate to have worked with you and Dick Males and Lindell, and and then Lou Rossman, same school and interactions with them. You learn these things about modeling, and it takes time and maturity, and I'm still learning about those things. But if that same drive to learn about modeling from its bare fundamentals without a computer program, it's not there, or it doesn't get fostered through other faculty who can nurture that, then to me, I would say, why we want to do physics-based water distribution systems analysis? Let's become Google-like, and then you have a AI model that just learns from different things and gives you some answer. And I think about it sometimes saying, we believe that the physics-based WDSA is a better thing versus a billion neuron that gets trained through 1 million water systems, real or fake simulation. In fact, it might give you a faster answer if there's a fast enough computer. But is that where you want our digital twins to be? And so to me, those over the next 10 years, I think those fundamental things have to be thought through. And I think we need to have a pipeline through the educational institutions and government organization that's going to nurture the minds who would continue to, keep the same passion for engineering above and beyond the passion for software and hardware.
You brought up AI, you brought up big data, a little bit off the wall. Any concerns, ethical concerns about where we're going in terms of collecting and using such data?
And so I think you have to take very careful and orchestrated approach towards some of it, but I think you should not say no to it. So a good example is medical data, and sharing if you are anonymized, and it's hard to almost therefore with other data to target you, saying, oh, that must be your data. But on the other hand, I think in terms of disease prevention and other things in the medical field, one can easily say that, yeah, if you had all that data, then you would know. And if you was a house, they find out through this internet saying, oh, this thing caused this, therefore this must be this. And you can therefore solve a particular complex case, with that knowledge. So to me, the big data and the water utilities are very, averse to sharing their data. But to me, even in water utilities, if you start analyzing data and start seeing the effects of, oh, we recycle pumps this way, then you would get the following effect. So to me, I think the big data has to be carefully managed, but I think there is clearly, in my mind, there are advantages in terms of sharing it, using it, and I think the ethics part is more on the people who are trying to do something with it. And so therefore, when we build our telemetry systems, we take security very seriously. Now, if that data after it ends up in some place in being used for good reasons or bad reasons, those become, more sort of questions. But I'm on the side of saying, be very careful about it, but try to share it.
Good. Any other thoughts you'd like to share with us about your work or anything else related to water distribution system analysis or technology?
I guess going back to the original thing that I started off with is, stormwater, wastewater, drinking water, source water, the different models seem to be figuring out which way to go. And there are different programming languages that have their advantages and disadvantages in terms of a particular way to use them. But in general, the bringing the different models together to solve a whole larger watershed problem is still another area I think that can get, it needs some advances so that the integration of multiple models that you can trust to solve a large problem together in a single thing versus, did this with these assumptions and we solved this thing with assumptions which may not match. So I think that would be one of the interesting, challenging to see how these multiple models evolve or integrate nicely to give us a bigger picture more accurately.
Sudhir, thank you very much. It's been a very enjoyable interview.
Thank you, Walter.